HSRP configuration guide. Hot standby router protocol HSRP. Addressing table R1 with 3 interfaces, R1, R2, 3 interfaces, R3, 3 interfaces. iNet is this cloud internet. Gigabit 001 with this IP address. Okay, this HSRP virtual gateway. Okay, 254, 1.254, S1, S3, PCA, PCB, and web server. Verify connectivity. Trace the path to the web server from PCA. Okay, go to PCA. And trace the path. Trace out the IP address of the web server 209.165.200.226. Okay, 4 hops. Which devices are on the path from PCA to the web server? Use the addressing table to determine the device names. Okay, 192.168.1.1, 192.168.1.1, R1, gigabit 01, R1, gigabit 01, first hop, 10.1.1.2, 10.1.1.2, gigabit 00 on R2, gigabit 00 on R2, second hop, third hop, 10.100.102, this 10.100.102, the cloud, this cloud, third hop, and the final hop is the web server, the web server. Trace the path to web server from PCB. PCB. Tracer 209.165.200.226. Four hops. First hop 182.168.1.3. First hop 192.168.1.3, gigabit 00 on R3, gigabit 00 on R3, first hop, second hop 10.1.1.2, gigabit 00 on R2, gigabit 00 on R2, second hop, third hop 10.100.102, 10.100.102, the cloud, this cloud, and the web server. Okay, which devices are on the path from PCB and to the web server? R3, R2, cloud, and web server. Observe the network behavior when R3 becomes unavailable. Select the delete tool from the Packet Tracer toolbar and delete the link between R3 and S3. Okay, this link between R3 and S3. Connections from gigabit 002 on S3 to gigabit 00 on R3. Very good. PCB tricert to web server. PCB tricert to web server. They request timeout. What are the results? The tracer command cannot determine the path to the web server because the path has been broken. Go to connections. And click on S3 gigabit 02 and click on R3 gigabit 00. Go to connections, straight through copper cable from S3 gigabit 02 to R3 gigabit 00. After link lights on the connection are both green, test the connection by pinning the web server. Pin should be successful. Okay, wait for the green indicators. Okay, Control C here to stop. Control C and ping or tracer the web server. Enter. Success. Configure HSRP active and standby routers. Configure HSRP on R1 here on R1. Configure HSRP on gigabit 01 LAN interface on R1. Okay. Gigabit 01 LAN interface on R1. Okay. On R1, enter. Enable configure terminal interface gigabit 01. Specify HSRP protocol version number. The most recent version is version 2. Standby version 2. Okay, standby version 2. Configure the IP address of the virtual default gateway. This address must be configured on any hosts that require the services of the default gateway. It replaces the physical interface address of the router that has been previously configured on the hosts. Multiple instances of HSRP can be configured on a router. You must specify HSRP group number to identify the virtual interface between routers in a HSRP group. This number must be consistent between the routers in the group. The group number for this configuration is 1. Standby group 1. Standby group 1. IP, the virtual IP 192.168.1.254. Okay. Remember, this is the virtual default gateway for HSRP 1.254. Enter. Very good. Designate the active router for HSRP group. It is the router that will be used as the gateway device unless it fails or the path to it becomes inactive or unusable. Specify the priority for the router interface. The default value is 100. A higher value will determine which router is the active router. If the priorities of the routers in the HSRP group are the same, then the router with the highest configured IP address will become the active router. Okay, configure priority 150. Enter. Standby group 1 priority 150. R1 will operate as the active router and traffic from the two LANs will use it as the default gateway. Okay, R1, the active router. If it is desirable that the active router resume the role when it becomes available again, configure it to preempt the service of the standby router. The active router will take over the gateway role when it becomes operable again. Standby group 1 preempt. Standby group 1 preempt. Enter. What will the HSRP priority of R3 be when it is added to HSRP group 1? 100, which is the default value. Configure HSRP on R3. Configure R3 as the standby router. Configure the R3 interface that is connected to LAN 2. Repeat only steps 1B and 1C above. 1B, configure the version. And 1C, configure the virtual IP. Okay, you will not configure the priority because you will use the default priority on R3. You will not use the preemption. Click on R3. Enter. Enable configure terminal. Interface gigabit. The connection to LAN 2 gigabit 00. 00. Standby version 2. Version 2. Standby group 1. Okay, should be the same group as the R1. And default virtual IP address 192.168.1.254. Enter. Enter. And that's it. Now priority. The priority on R3 will be the default value 100 and no preempt. Verify. On R1, show standby. Go to R1 and show standby. Okay, show standby. Gigabit 01. This gigabit 01. Active router is active on group 1, version 2. Virtual IP address 192.168.1.254. Active virtual MAC address, this MAC address 0C9FF001. Local virtual MAC address. Okay, 0C9FF001. Preemption enabled, priority 150. Active router is the local, so this is the active router, and standby router is 192.168.1.3. Okay, R3. 192.168.1.3, R3. On R3, enter and show standby. Enter. Okay, show standby on gigabit 000 group 1, gigabit 000 on R3. State is standby. This is the standby router. Virtual IP 192.168.1.254. Active virtual MAC address. This 0C9FF001. Local virtual MAC address 0C9FF001. Preemption disabled. Active router 192.168.1.1, this R1. Standby router is the local router, so R3 is the standby router. Priority by default 100. Using the output, answer the following questions. Which router is the active router? Okay, click on R1. Active router is local. Okay, R1. What is the MAC address of the virtual IP address? This active virtual MAC address 000/0C9FF001. What is the IP address and priority of the standby router? Okay, R3 is the standby router. The priority is 100. Okay, 100 on the standby router, and the standby router is 192.168.1.3. R3. Show a standby brief on R1 and R3. R1, show standby space brief, and brief, enter. Okay, on interface gigabit 01, the group is 1, priority 150, preemption, active router, R1 is active router. The active router is local, standby is R3, 192.168.1.3, and virtual IP 254. Go to R3, show standby brief, enter. Interface gigabit 00, group 1, priority 100, no preemption. State this is on standby router. Active is R1, 192.168.1.1. Standby is the local router, virtual IP 254. Change the default gateway address for PCA, PCC, S1, and S3. Which address should you use? Okay, use the virtual IP 192.168.1.254. PCA 254, PCB 254, S1, enter, enable configure terminal, show, okay, and show running config. This is the current IP and default gateway. Change the default gateway. Configure terminal. IP default gateway 192.168.1.254. Enter. S3. Enter. Enable configure terminal. Default gateway 192.168.1.254. Okay, IP default gateway. Very good. Verify the new settings. Ping from PCA, PCC. Okay, it should be PCB. Okay, to web server. Are pings successful? PCA. Ping to web server. Ping 209.165, 200, 226. Success. Okay, PCB. Ping to web server. Success. Observe HSRP operation. Make the active router become unavailable. Open command prompt on PCB and enter command tracer 209.165, 200, 226. Okay, go to PCB, this PC, and tracer to the server. Tracer, enter. Okay, you have 4 hops. Okay, the first hop is 192.168.11 is R1 with gigabit 01 on R1, gigabit 01 on R1. Second hop 10.112 is gigabit 00 on R2. The second hop gigabit 00 on R2, 10.112. Okay. No, third hop 10.100.102. 10.100.102 is the cloud. This interface. Finally, the web server. Does the path differ from the path used before HSRP was configured? Okay, this is after configure HSRP, and this is before to configure HSRP. The only difference is the first hop. The first hop is 1.3 R3, and after the first hop is 1.1 R1. Okay, does the path differ? Yes, the path now passes through R1 instead of R3. Break the link to R1. Select the Delete tool from Packet Tracer toolbar and delete the cable that connects R1 to S1. Delete this cable. Okay, this tool, delete, and click here, and click here. Immediately return to PCB and execute tracert. PCB. Repeat the command. Okay, very good. Here is a request timeout message. Okay, and repeat again. And this is better. Observe the output of the command until the command completes execution. You may need to repeat the trace to see the full path. Okay. Repeat and you will see the full path. Okay, this is R3. 1.3 is R3. This is R2. R2. This is cloud. This is the cloud. And this is the server, the web server. How was this trace different from the previous trace? At first, the trace timeout. Okay, eventually the trace goes through R3, R2, the cloud. Okay, so the difference is the first hop. In this case, R3 is used, and before to remove the cable, R1 was used. HSRP undergoes a process to determine which router should take over when the active router becomes unavailable. This process takes time. Once the process is complete, the R3 standby router becomes the active and is used as the default gateway for hosts on LAN 1 and LAN 2. Okay, for example, verify on R3, enter, show standby brief. Now, the state, this R3 is the active router. And the active router is the local router, R3. And the standby router is unknown because R1 is disconnected. Okay. Restore the link to R1. reconnect R1 to S1 with copper straight-through cable. Okay, remember on R1, not the remember on R1 the interface is gigabit 01 for the internal LAN, gigabit 01. Okay, use this cable gigabit 01 to gigabit 02. Okay, gigabit 01, 02. Execute the trace from PCB to web server, PCB trace to web server. And you may need to repeat the trace to see the full path. Okay. Okay, request timeout messages. Repeat. Okay, you will see the full path. Okay, this is full path, also full path, but with missing information. Missing information. This is the full path with complete information. What path is used to reach the web server? Okay, this is R1, R2, the cloud and web server. Okay, R1, R1 again, R2, the cloud and web server. If the preamp command was not configured for the HSRP group on R1, would the results have been the same? Okay, no, R1 will not become the gateway again. The path through R3 would continue to be used. Completion 100%. Thank you very much.